Back in November, the UK's own climate scientists sat down and tried to predict what this storm season would look like. Some models said it was stormy, some models said the exact opposite, and what actually happened over the following months managed to catch almost everyone off guard. To understand just how strange this storm season has been, you first need to understand how uncertain forecasters were before it even started. Researchers at the National Center for Atmospheric Science laid out the situation in blunt terms last November. Different seasonal forecasting models were pointing in completely different directions. The Australian and French models predicted a windy, stormy winter. The European and Japanese models predicted the opposite. Even the UK's own Met Office model showed no clear signal either way. One expert described predicting a stormy season as intrinsically difficult, largely because storm behavior varies so wildly from year to year that patterns are hard to lock onto in advance. There was also talk of something called a sudden stratospheric warming, a rare atmospheric event that, when it happens, tends to weaken storm activity and bring colder, calmer conditions instead. One researcher pointed out that this kind of event happening as early as November would be almost unheard of, since it hadn't occurred that early in the season since 1968. The presence of a weak polar vortex made forecasters cautious. It suggested the storm season could end up quieter than usual, not more intense. So going into winter, the honest answer from the people whose job it is to know this stuff was essentially, we're not sure. And then the season began, and what followed didn't really match any single one of those competing predictions. Storm season kicked off on the 8th of January with Storm Goretti, and it moved fast. On the 6th of January, an Atlantic low-pressure system started developing at a relatively unremarkable 1,020 hectopascals. Within 24 hours, it had deepened to 1,017. That might not sound dramatic, but pressure drops in storm systems are measured in a way where every single point matters. By midnight on the 8th, the system had plunged to 1,006 hectopascals, and it kept falling, losing 2 hectopascals every single hour, hitting 994 by 6 in the morning. That kind of rapid deepening is exactly the pattern meteorologists watch for when a storm is about to become genuinely dangerous rather than just disruptive. Storm Goretti ended up triggering a red warning, the most severe category the UK issues, for damaging winds across the Isles of Scilly and parts of Cornwall. Red warnings mean danger to life. They are not issued lightly, and they weren't expected to be needed this early or this often, in a season several models had suggested might actually be quiet. Then came Storm Chandra, later that same January, and it brought something forecasters specifically flagged as unusual. Strong easterly winds hit parts of Northern Ireland, and easterly winds of that strength are genuinely rare for the UK, since most of the country's severe wind events arrive from the west, driven by the standard Atlantic. Storm track. When a storm forces air to move in the opposite direction with real intensity, that's already a sign something about the season's usual patterns has shifted. Storm Chandra also delivered an amber rain warning across South Devon, much of Dorset, southern Somerset, and southeast Cornwall, with 30 to 50 millimeters of rain expected widely, and as much as 60 to 80 millimeters over the higher ground of South Dartmoor. And this rain wasn't falling on dry, absorbent ground. It was landing on catchments that had already been saturated by days of persistent wet weather beforehand, dramatically increasing the risk of flooding well beyond what the same rainfall total would have caused earlier in the season. Here's where the numbers get genuinely remarkable. During the same unsettled pattern that preceded Storm Chandra, on New Year's Day, several UK weather stations didn't just record heavy rain, they broke all-time January daily rainfall records that had stood for decades. Catesbridge in County Down recorded 100.8 millimeters, completely shattering the previous record of 38.2 millimeters, which had stood since 2005. Dunkswell Aerodrome in Devon recorded 52.8 millimeters, beating a record from 1986. Herne in Dorset broke a record from 1970. Cardinham in Cornwall beat a mark that had stood since 1999. Plymouth Mountbatten in Devon surpassed a record from 1965. Read that list again. Records going back 60 years, broken in a single day, at multiple locations across southern England and Northern Ireland simultaneously. That's not a normal wet spell. That's an exceptional atmospheric event. And it happened in a season where models genuinely couldn't agree on whether things would even be stormy at all. It's worth pausing on what records like these actually mean for the people living through them, beyond just the impressive-sounding statistics. When a drainage system, a river channel, or a flood barrier is designed, engineers use historical rainfall data as their baseline, the same 60-year-old numbers that just got broken. That means the infrastructure protecting towns near Catesbridge or Dunkswell was built around assumptions that this January quietly proved outdated in a single afternoon. Emergency services in several of these areas reported having to respond to surface water flooding on roads that had never previously been flagged as flood-prone, precisely because the old data never suggested they needed to be. By the time Storm Dave arrived over the Easter weekend in early April, forecasters were watching a very different kind of season take shape than the one they'd cautiously predicted back in November. Storm Dave brought damaging winds, heavy rain, and unusually late-season snow to higher ground in Scotland, capping off a winter that the Met Office would later officially describe as both warmer and wetter than average, with 4 separate named storms in total. So what actually drove this? According to the Met Office's own analysis, the answer comes down to an unusually powerful jet stream that took a more southerly route than normal. Think of the jet stream as a fast-moving conveyor belt of air, high above the UK, that steers Atlantic storm systems toward or away from the country. This particular winter, that conveyor belt was working overtime. Storms that, in a typical year, might have weakened out over the ocean or veered off toward Iceland or Scandinavia. Instead, traveled directly and efficiently across the Atlantic and straight into the UK, one after another, in close succession. The reason the jet stream behaved this way traces back, somewhat surprisingly, to conditions over North America. Repeated outbreaks of freezing Arctic air clashed with warmer air further south, and that sharp temperature contrast is exactly the kind of fuel that energizes and strengthens the jet stream. At the same time, the jet stream's position shifted further south than usual, dragging the UK's wettest weather with it into regions like the southwest of England, eastern Scotland, and the east of Northern Ireland, areas that don't always bear the brunt of the season's worst rainfall. Interestingly, that southerly shift meant western Scotland, normally one of the wettest parts of the entire country, ended up drier than usual this season, positioned just north of where most of the storm track was actually running. It's a reminder that the UK had a wild storm season, doesn't mean every region experienced it the same way. Some places broke 60-year rainfall records, others had a comparatively quiet few months. There's also a blocking pattern worth understanding here, because it's part of why the season felt so relentless rather than just occasionally bad. A blocking high-pressure system parked itself over Scandinavia for weeks at a time, and its effect was almost like a wall further along the storm's path. Instead of letting low-pressure systems clear away, quickly to the east, as they normally would, that block trapped an extended spell of wet weather in place over parts of the UK, forcing successive storms to queue up one after another, rather than arriving with breathing room in between. That's part of why so many places felt like they barely dried out between one system and the next. Climate change adds one more layer to this whole picture, and it's a layer scientists are increasingly confident about even when specific seasonal forecasts remain uncertain. A warmer atmosphere holds roughly 7% more moisture for every single degree Celsius of warming. That means when a storm does form and pull in moisture, it now has more fuel available to convert into intense, concentrated rainfall than storms had access to a few decades ago. The unpredictability of exactly which storms will form in any given year hasn't gone away. But the ceiling on how extreme those storms can be, once they do form, keeps rising. This is really the heart of why this storm season caught so many people off guard. It's not that forecasters were careless or that the science failed, it's that predicting the exact number and timing of storms months in advance remains genuinely difficult, even for world-class meteorological models, because storm formation depends on so many overlapping atmospheric variables. But once those storms do arrive, the backdrop they're forming against, a warmer, moister atmosphere, means each individual event carries more potential for extremes than it would have a generation ago. You can have a season where the seasonal outlook shows no clear signal and still end up with 4 named storms, a red warning, an unusual easterly gale, and rainfall records that had survived since the 1960s, all getting broken on the same day. The Met Office has been direct about what this likely means going forward too. Future winters are expected to continue this same trend, bringing more heavy rainfall days, and a growing chance of multiple storm systems arriving in close succession, rather than differences will keep existing, the way Western Scotland caught a break this year while the Southwest didn't. But the broader shape of the pattern, wetter, more unsettled. De-winters becoming a normal part of the UK's climate is the direction every current model agrees on, even when they can't agree on the details of any single season. There's a practical takeaway hiding inside all of this, and it's worth carrying forward into every future storm season, not just this one. Seasonal forecasts, by their nature, are working with incomplete information months ahead of time. That doesn't make them useless, but it does mean they're better understood as a range of possibilities, rather than a firm prediction. The real, actionable warnings only sharpen into focus days, sometimes just hours, before a storm actually arrives, which is exactly why staying tuned to the short-range forecasts and official warnings matters far more than memorizing what the seasonal outlook said back in autumn. So the next time you see a seasonal outlook that shrugs and says the signal is unclear, don't take that as reassurance. As this season proved, unclear doesn't mean nothing is going to happen. Sometimes it just means the exact shape of what's coming genuinely hasn't revealed itself yet, right up until the moment a low-pressure system starts dropping 2 hectopascals an hour out in the Atlantic. If stories like this, the ones connecting the dots between what forecasters expected and what actually happened, are the kind of thing you want more of, go ahead and subscribe. Because this storm season is far from the only place where the numbers told a very different story than the headlines did. And if you found this useful, tap that like button before you go. It genuinely helps more people find channels doing this kind of deeper dive. It's worth pausing on what records like these actually mean for the people living through them, beyond just the impressive sounding statistics. When a drainage system, a river channel, or a flood barrier is designed, engineers use historical rainfall data as their baseline, the same 60-year-old numbers that just got broken. That means the infrastructure protecting towns near Catesbridge or Dunkswell was built around assumptions that this January quietly proved outdated in a single afternoon. Emergency services in several of these areas reported having to respond to surface water flooding on roads that had never previously been flagged as flood-prone, precisely because the old data never suggested they needed to be.